The James Webb Space Telescope, a marvel of modern astronomy, has recently unveiled a discovery that could fundamentally alter our perception of the cosmos and our place within it. Scientists have detected a series of mysterious flickering lights emanating from a rocky exoplanet located just 4 light-years away, known as Proxima b, which orbits Proxima Centauri, the closest known star to our Sun. Proxima Centauri, a red dwarf star, is notorious for its erratic and intense bursts of radiation, including powerful solar flares that can bombard nearby planets with high-energy particles. The nature of these intriguing lights remains shrouded in uncertainty, prompting fervent debate among researchers worldwide. Are they signals from an advanced extraterrestrial civilization, broadcasting their presence across the vastness of space? Or are they merely the product of some yet-to-be-understood natural phenomenon unique to this alien world? The answer, for now, eludes us, but the implications are profound. Proxima is far from an ordinary exoplanet. It's distinguished by its tantalizing proximity to Earth and its peculiar orbital dynamics. Due to its close orbit around Proxima Centauri, the planet is tidally locked. It's a gravitational phenomenon where one side of the planet perpetually faces the star, bathed in relentless light and heat, while the opposite side remains plunged in eternal darkness and frigid cold. This creates an extreme dichotomy across the planet's surface. One hemisphere is scorched by the star's intense radiation, potentially reaching temperatures that could vaporize rock, while the other is frozen in a deep, icy chill. However, at the boundary between these two extremes lies a region known as the Terminator Line, a twilight zone, where light and shadow meet, and temperatures might be moderate enough to support life. If Proxima b possesses an atmosphere capable of redistributing heat from the star-facing side to the dark side, this Terminator zone could harbor conditions suitable for liquid water, a key ingredient for life as we know it. Preliminary observations from the James Webb Telescope have sparked excitement by detecting possible traces of water vapor, methane, and even oxygen in Proxima b's atmosphere. Though these findings are tentative and require further confirmation through rigorous analysis, perhaps the most captivating aspect of this discovery is the detection of these unusual lights on Proxima b's surface, which have ignited the imaginations of scientists and the public alike. Unlike random bursts of energy, these lights exhibit a consistent, non-random pattern, suggesting they may not be mere fleeting anomalies. This regularity has led to widespread speculation about their origin. Some researchers propose they could result from natural processes unfamiliar to us, such as luminescent chemical reactions in the planet's crust, perhaps triggered by the intense radiation from Proxima Centauri, or volcanic activity releasing glowing gases or molten material. Others, however, dare to entertain a more extraordinary hypothesis. These lights might be artificial, akin to the city lights visible from Earth's orbit at night. If this bold idea holds true, it would represent the first direct evidence of an advanced extraterrestrial civilization, one capable of harnessing the energy of its volatile star to sustain itself. Such a discovery would be a monumental milestone, challenging everything we believe about the prevalence and resilience of intelligent life in the universe. Proxima Centauri's nature as a red dwarf star adds complexity to the puzzle. Red dwarfs are smaller and cooler than our Sun, but they are prone to violent solar flares that can unleash torrents of ultraviolet and X-ray radiation. These flares could strip a planet like Proxima b of its atmosphere over time, rendering it barren and inhospitable. Despite this harsh environment, some scientists hypothesize that life on Proxima b could have evolved to survive such conditions. For example, organisms might thrive underground, shielded by layers of rock from the star's punishing radiation, or beneath thick sheets of ice that act as a protective barrier while allowing liquid water to exist below. On Earth, life has demonstrated remarkable adaptability, flourishing in extreme environments like the scalding hydrothermal vents of the deep ocean, the acidic pools of volcanic regions, and the frozen expanses of Antarctica. If life on Earth can endure such conditions, it's conceivable that life on Proxima b could have developed similar resilience. Perhaps in forms utterly alien to our understanding, this discovery marks only the beginning of a new chapter in astronomical exploration. James Webb Telescope's data is just the first glimpse, and upcoming instruments promise to deepen our understanding. The Extremely Large Telescope (ELT), currently under construction, will use its massive 39-meter mirror to capture unprecedented details of distant worlds. Similarly, the Habitable Exoplanet Observatory (HABEX), a proposed space telescope, is designed to block out starlight with a starshade, allowing direct imaging of exoplanets like Proxima b. These tools could reveal surface features, atmospheric compositions, and even biosignatures with far greater clarity. Meanwhile, the Breakthrough Starshot Initiative is pushing the boundaries of exploration by developing tiny, laser-propelled spacecraft, each no larger than a postage stamp. These probes could travel at 20% the speed of light, reaching the Proxima Centauri system in just a few decades. If successful, they could beam back high-resolution images and data, offering an up-close look at Proxima b's surface and its mysterious lights. The scientific implications of the lights on Proxima b are staggering. If they are artificial, they would provide the first tangible evidence of intelligent life beyond Earth, raising profound questions about the civilization responsible. Who or what created these lights? Are they the product of a society far more advanced than our own, capable of engineering megastructures or energy systems visible from light years away? How have they survived the brutal radiation of their star? Moreover, this discovery challenges our traditional notions of habitable zones, the regions around stars where conditions are thought to be just right for life. We've long assumed that life requires Earth-like planets with stable atmospheres and mild temperatures. But Proxima b's extreme environment suggests that adaptability may be a more critical factor. If life thrives there, it could mean that the universe is teeming with life in places we've previously dismissed as uninhabitable. From the icy moons of gas giants to the scorched surfaces of planets orbiting volatile stars, the discovery has also opened the door to exploring other nearby exoplanets. If Proxima b hosts life, what might we find on worlds like LHS 1140b, a super-Earth in a potentially habitable zone, or the 7 Earth-sized planets of the TRAPPIST-1 system, some of which may also harbor conditions suitable for life? The cosmos could be far more vibrant and diverse than we've imagined. With life taking forms we can scarcely comprehend, perhaps silicon-based organisms, or entities that thrive on radiation rather than sunlight. Public interest has exploded in response to this discovery, with social media platforms abuzz with theories ranging from the plausible to the fantastical. Academic institutions are hosting symposiums and debates, grappling with the philosophical and ethical ramifications. Some political leaders advocate for caution, urging scientists to verify the data meticulously before jumping to conclusions about extraterrestrial intelligence. Others see the lights as a beacon of hope, a potential confirmation that humanity is not alone in the vast expanse of the UHAs. This finding has also reignited discussions about communicating with any potential intelligence on Proxima b. For decades, projects like the Search for Extraterrestrial Intelligence SETI have scanned the skies for radio signals, with no definitive results. Now scientists are contemplating using powerful radio telescopes, such as the Arecibo Observatory successor or the Square Kilometer Array, to send targeted signals toward Proxima b. However, this idea raises significant ethical questions. Should we broadcast our presence to a civilization about which we know nothing? What if their intentions are hostile, or their technology so advanced that contact could have unforeseen consequences? Conversely, if the lights are natural, they could reveal new geological or chemical processes, expanding our understanding of planetary science. Ultimately, the lights on Proxima b compel us to rethink our assumptions about where and how life can exist. For decades, we've searched for Earth-like worlds, assuming that life requires conditions similar to our own. But this discovery suggests that life might arise in the most unexpected places, defying our preconceptions. The lights are artificial. We could be observing a civilization that has overcome immense environmental challenges, pushing the boundaries of what we believe is possible in biology, technology, and survival. Even if they are natural, they hint at processes we've yet to encounter. offering a window into the diversity of the cosmos. As we stand on the cusp of a new era in interstellar exploration, tools like the Extremely Large Telescope and Breakthrough Starshot will bring us closer to answering these questions. Some scientists even envision human missions to the Proxima Centauri system in the distant future, perhaps using advanced propulsion systems yet to be developed. For now, interpreting the lights on Proxima b remains our immediate challenge,